Lucata converges compute and memory architectures to solve the next wave of big data, artificial intelligence, and machine learning and application problems without unnecessary software layers or virtualization. Let's take a look at a few of Lucata's advantages. Lucata made it a priority to do this without requiring new programming models. Our solutions leverage familiar, industry-standard software and are straightforward to query and program. We do this while building energy-efficient technology solutions that dramatically reduce data movement, which results in reduced power consumption. Lucata's breakthrough technology includes a cacherless design that overcomes previous generations' shared memory inhibitors, which include coherency, cost, and complexity. Migrating thread technology that dramatically reduces data movement across the network. We move the tiny program context rather than large data chunks. Truly scalable shared memory, which simplifies programming as compared to clusters with MPI or GPUs. This enables breakthrough capabilities for NewSQL, graph query, and data science-focused databases with integrated machine learning. Let's take a look in more detail at how Lucata's computing technology works and why it's better than other architectures for sparse data, data analytics, and hybrid databases. A cluster is a group of independent servers that do not share memory. Programmers use message passing to send work, or data, from one system to another in the cluster. Since the servers are independent, each action requires 4 steps. An MPI read request from the initiating server, an ACK or acknowledgement from the target server, an MPI read response, and another acknowledgement. Why so much waste in each packet? Because a minimum packet size is set by the IT administrator to ensure overall network efficiency when data is transmitted. Typically, this minimum is 256 or 512 bytes. Individual applications can use a bigger size, but cannot use a size smaller than that set by the admin. So a huge amount of wasted or empty bytes are transmitted, ×4 for each transaction. In Lucata's novel design, the program context is moved across the network instead of the data. The data set resides in a shared pool of memory. Using the same example, only 144 bytes is transferred over the network instead of 3072 bytes, as in a traditional cluster, greatly improving both speed and efficiency. Let's take a look at a more specific example. Here we have a random read operation typical of a database index. In a conventional cluster, large network packets of two-way transfer per access each consume approximately 1 kilobyte of network bandwidth. Massive amounts of data spread over the many independent memories is highly inefficient. Along with the 3072 bytes for MPI packets, data itself is also sent over the network. This is a minimum of 256 bytes, though typically would be 1 gigabyte or more of data sent to the CPU requesting it. Contrast the data movement in a conventional cluster with the Lucata system. In Lucata's novel design, only the program context is moved across the network instead of the data. The same random read operation demonstrates Lucata's efficiency for critical functionality like database indexes. Our small packets have no wasted bytes, only travel one way per access as compared to 4 for a cluster, and consume only 48 bytes per packet over the network. No data is moved at all. The result is better usage of the network, coupled with high-performance random reads and indexed queries. The key advantages are that tiny program contexts move across the interconnect instead of large data chunks. There are no wasted bytes moving program context, and Lucata uses 1/20th the network bandwidth of a traditional system. Thank you for taking a brief look at how Lucata's technology converges compute and memory architectures to solve the next wave of big data, artificial intelligence, machine learning, and application problems. To learn more about our innovative, scalable technology and how it can help solve your big data analytics problems, visit lucata.com.